class. I'm audible. Good morning, class. I'm audible. I'm audible, class.
Yes, sir.
Yes, sir.
Can anyone repeat what we are doing in the last class? We are talking about IP addressing scheme. Yes. If you have any doubt or query, you can ask. So we are talking about network layer, and we all know why we need this layer, role and responsibility of network layer, which basically help us to identify uniquely. We can identify the node uniquely. For that purpose, we need IP address, right? Now, in this layer, the role of router come in picture for this reason, right? Because hub and switch, they are working in physical layer, and switch is working in your data link layer. Now, for network layer, these two devices will not work, right? For network layer, we need a specific device which is known as router. So please remember this thing. So layer 3 device that we have for communication between nodes of different network, we use off router, right? So we have studied that how subnet mask was find out for every class, right? So please remember this thing. One more nomenclature that we now today I will introduce, that is known as CIDR, right? What it means? It means the number of bits required for network address, right? So this is another way of representing this 255.0.0.1. So since we are using the first 8 octet, so that's why we are using slash, that is CIDR, that is how much? 8. And in class B we are using 255.255, so it means another next octet is also in use, so that's why we have slash 16, 8 plus 8, 16. 8 bit for the first octet, next 8 bit on the second octet, right? So that's why we are having 16 over here, right? And for class C, you can see the first octet, the second octet, and the third octet now in use. So it means 255.255.255. So the CIDR value for class C will be slash 24, right? So this is for classful addressing scheme, right? In classless, this value will not be fixed. It can be any value. It can be slash 9, slash 10, slash 12, right? Depending upon the subnet that we want to create. But for classful, these values will remain fixed. Please remember this thing. Yes, class. This value will remain fixed for classful addressing. So for class A, the CIDR value will be slash 8. It means the 8 bits, first 8 bits we are used for network address. and the remaining bits that we have, that is 24 bits, that will be used for host addressing. Similarly, for class B, you can see the subnet mask will be 255.255.0.0. So it means we are using this 8 bits and the next 8 bits also. So that's why the CIDR value will be /16. We can represent in this manner also, right? So suppose if it is there 10.1.1.1, this is an IP address with /8. So it means that this is a class A address scheme and it is a class full addressing scheme since we are using that /8, right? Now it can be /9 also, but in that case that will not be class full addressing, it will be classless. Please remember this, it will be classless addressing scheme, right? /9, /10. What it means actually, /9 means that the next bit also we have consumed for network address. So this one. So now how many bits? 1, 2, 3, 4, 5, 6, 7, 8. And in the next octet, the first bit is also consumed for network address, right? So that's why it will come /9. How about /10? /10 means the next bit also is being used for network address. So it means 1, 2, 3, 4, 5, 6, 7, 8, the first octet, and the next 2 bit of the second octet is also consumed for network address. And the remaining that we left with 7, 8 will be your host address, like this, right? Please remember this thing. And the next octet, that is also having 8 bits. So we will write like this way, right? Like this way. So this, if we talk about the CIDR value in this particular case, so you can calculate the first octet, that is 8 bit, and the next 2 bit is also consumed for network address. So this is what the CIDR value will be /10. And this is the case of classless addressing, right? In classless addressing, we are not considering all the bits for host. We are dividing that block into subparts so that the wastage of classes, the wastage of IP address that we have talked in the previous class, yes, the wastage of IP address uh, will not be considered, right? My voice is not clear. Yes, Kanika, I'm not audible. From my side, I have kept full volume. Yes, class, my voice is not clear. Please respond.
Say it's properly clear.
Okay.
Yes, sir, clear.
So please remember that that CIDR value means the number of bits that we are going to consume for network address, right? Yes, class. Any doubt for CIDR? Now suppose if I am talking about /24 is there, so
Sir,
/25.
question. Sir,
So
एक बार
what it
समझा दो
means,
CIDR.
/25 means we are consuming 25 bits, first 25 bits in this sequence for network address, and the remaining bits will be consumed for host IPs, right? So how we are doing that? So as we all know, for ClassFull that we have 24. So the nearmost, that CIDF for ClassFull we have 24. So the first octet will be consumed, the second octet will be consumed, the third octet will be consumed. That is 8 into 324, right? Is so what we have. So we are talking about 25. So 24 plus 125. So it means the next bit also in the remaining octet. So we are left with only last octet. In that, the first bit is also consumed for the network address, right? So this is how we are subdividing the big network. And the problem that we are having, that since in ClassFull we have a large part of addressing, and if it is not required by our network, then what we are doing, we are just wasting the address, and it is very costly. IP address is very costly, right? For suppose in our organization, we have one IP from one network, from suppose BSNL, one IP from we have taken from Reliance Jio, right? So you can see we are paying for this single IP only, and this single IP is serving the entire PC, the computer that we have in our college. You can see how many PCs are there. In every lab we have 30 to 40 PC. So how it is working? It is working with that server we have given that IP, and we are making a proxy server for that, right? Now proxy server will serve, and then we will do a NAT over here, that is network address translation. So the concept of private IP will come in picture, private IPs. So the organization who have designed this IP address, they understood this thing, that it is not mandatory for everyone who have a PC in their home to buy a IP address to run the internet. So there need to be some method also that can help them to share the IP, to share the network in some sense. So what we can do, or you can see this example also, if somebody has 300 PCs, then there is a need of 300 IPs, which is very costly, right? Or what we can do, we can buy one IP, and then with the help of network address translator, what we are doing, this IP will be shared among all the PCs, all the computers, all the hosts that we have in an organization, right? And how it is working with the help of network address translation. So there will be mapping of public address. So this is known as public address, right? And this is known as private address. So there will be mapping of public address and IP. So private address can be given to any PC. There will be no cost for that. So there is a set of private IP address that we can allot to our PCs, and then this PC will serve with the help of this server that is known as network address translator, right? And how it is working? Uh, when a packet want to transmit to outside a network, then we will put encapsulation of public address on that private address, and this table will be maintained by NAT, that is known as network address translator. So there will be a list of private address with the MAC address, right? And every packet that wish to reach to outside network will be encapsulated with the public address. This is how it will reach to that destination. And similarly, when it will come back, right? So we will maintain that table, and through that table, we will see which private address has requested for this particular query. And then for that particular MAC address, it will reach to the unique system through our hub or switch that we have, right? I will explain this thing in detail when this topic will come in the next slide. But this is how the role of public address and private address will come in picture. That's why it is needed,
Just
because IP addresses are not so economical. They are very costly, and you can see even a single IP can serve the entire organization, right? So we have to pay for it for a monthly basis and yearly basis, depending upon the discretion by the organization. So what we have, the next thing that we have, that classful addressing, which is almost absolute and is replaced with classless addressing, right? So that's why I'm saying that it is fixed in case of classful, that is /8, /16 and /24. It is fixed. So if I required only 10 PC in class A, then how much nodes how much IPs 2^24 I am wasting out. In this case also, if I need 100, then you can see 2^16 host that I'm simply wasting out. In this case, suppose I need only 5 IPs or 5 nodes, that need to work. So 2 raised to power 8. That means 2 raised to power 256 in this case. And in this case, 65,500 IPs that can we have. So you can see that how many wastage of address we are doing with ClassFull addressing. So that's why we transfer for this classless addressing, where we are not fixed with this /8, /16 and /24. So it means that CIDR value is now going to be depending upon the requirement of the user. If a system required only 5 PC, then we can go with, you can see with class C address where we have /24. So we can increase the CIDR value from 24 to 28. So how many bits are left? If we subtract it from 32, 28, we are left with how much? 4. So 2 raised to power 4, that is how much? 16. Still, it is more. So it means we can consume one more network bit. So /29. If /29 is there, so how much we are left with? Only 3 bits. So 2 raised to power 3. That will be how much? Yes. So how much is required? 8. So this is much appropriate for a network with 5 devices as compared to allotting a network in which we can create 16 or 256 or 65,500, so on, right? So we are working on this category where we are saying that how to avoid the wastage of IP address, since we know that we are increasing day by day, and lots of PCs and even the network devices that are coming around to us, and they need IP addresses, right? This thing we will study later on, but before that I just want to give you an example that we have just talked about in packet tracer.
The
Just hold on.
CIDR.
Yes, CIDR value just deal about the number of bits that we are using for network address. Clear?
Okay, sir.
Right. So I'm just clearing you out the role and responsibility of network layer, and this particular practical will explain you and clear lots of your doubt. Just please pay attention over here, right? Since I have a guest version, we have to wait for 3-4 seconds, then it will automatically get logged in. Yes. So now this is the screen, right? So as I told you earlier also that till now we have talked about the devices, and we have AND device. If we want to connect them directly, then we can make use of cross cable, and there is a need to provide an IP address in between them. Now, how about if we want to connect more than 2 computers, then the role of a hub come in picture, right? So where we can connect multiple devices, more than 2 devices, and there is no need of cross cable. So this was the example, and you all know that hub works at physical layer, right? And hub is a single collision domain, right? Where hub basically perform broadcasting, right? Like this way. So if you want to connect more than 2 PC, then we need hub. Now, still hub have some challenges. If we have heavy traffic, then this hub will not work, right? Then question may arise in your mind, then why there is a need of hub? And I have already answered this question. We need hub since it is economical, and for small network we can go for it, right? It is fair enough to use hub because switch is more intelligent, and it performs some kind of unicasting as compared to broadcasting, which is done in hub, right? So they are from main family, and where you can see switch will have multiple collision domain depending upon the number of active ports. You can see Now the interface is more as compared to hub. So till now we have talked about this thing, that how we are going to connect with switch. So switch also provide many interface, and switch provide uh, us for heavy traffic. It is helpful for use in heavy traffic where multiple nodes are connected, and it gives us again example, like in this we can say that number of active ports, depending upon the number of active ports, the collision domain will vary, right? Now for network layer, the next device that we have, that is switch, that is router, sorry. So now the router will come in picture. And why it is come in picture? Because switch has a limitation that it can work for a LAN network, it can work on a similar network, right? How about when we are working for different network? So I'm going to prove this theory. You can see, so just now we have talked about the IP addressing scheme where we have class A address. So we have used one class A address 10.0.0.1. The screen is visible to all? Yes, class? Right. So I am taking class A over this side, PC6 and PC7. I'm using this thing. What we are doing, I'm just showing you that different network will not able to work without the help of router. It means switch is not capable to connect different network. Switch is only manageable in LAN network, local area network. What it means that in that network, all nodes must be in same network. If they are in different network, then switch will not work. I'm just going to show you that, right? So here I have given an IP address of 10, and now on the other end, I will give an IP address of class C, suppose, and class C ranges in 192.168.1.1, where subnet mask is 255.255.255.0, right? Similarly, for this one, I have taken a class C 192.168.1.2 and subnet mask of 255.255.255.0. Now you can see we are working on different network. So if we are in different network, how we can able to communicate? You will see it will fail out, right? Packet, as many time we will try, in every attempt you will find that packet is not going to deliver on the other side. Now here, this is the situation where the switch gets failed, right? And that's why there is a need of router in picture, and which says that to connect different network we need router. Yes. Now if you can see, I'm just showing you, if I put it back to the class A addressing 10.0.0.3, that is 255.255.0.0.0, right? And PC9, which is also in class 10.0.0.4, and we have 255.0.0.0, right? Now it is in same class, in same network. So what we can have, you can see it is successful. Yes, class? Any doubt in this particular? So this is the objective of this particular chapter, network layer, which says that how to connect, and the role of router come in picture, how to connect different network, and till now, till data link layer, switch is working with the help of MAC address and IP address. But the problem is that for different network, hub and switch is no more able to work. Yes, class? Any doubt? Yes.
एक बार रिपीट कर दो सर कैसे कनेक्शन
Yes. What is your doubt? Please ask clearly.
सर वो कैसे किया PC1
PC6 to PC8. Before we have assumed different network right? What we are learning in this particular is that whether different network will able to work with the help of switch or not, right? We are learning data link layer, and data link layer is talking about your switch, and we are using switch over here. We are talking about MAC, that is 48-bit address, right? But the entire world is not working on same network. Yes, when we are talking about global communication, the network, other countries they have different network, other state even they have different network, other organization they have even different network. We cannot have a single LAN for entire state, for entire country, for entire world. They are they have their own IPs and they are working according to their need. So they have their own network. So if we only use switch, then it is not possible for us to connect to different network. Then what is needed? Then the role of router come in picture, where it help us to connect with different network. Now the same thing I will tell you with the help of this. If we have used, yes, yes class, please mark your present by writing present in your chat box, all of you. So I'm going to demonstrate how switch is a suitable device for us to communicate with different network, right? So in this side we have taken one network which is of class 10, and on the other side we will take another network which is of another class C, that is 192.168 something, as you wish. So I'm taking it 192.168.1.1, right? And other PC which is again connected with 192.168.1.2, right? Now this is a different network. I'm just renaming it for your reference. That is 192.168.1.1. This is 192.168.1.2, and on the other side I'm just deleting the switch and hub case so that you can see the clear picture of this particular. Yes, and this is very important practical, and this is the final output of this chapter, right? So what we are doing, on the other side we have an IP address of 10.0.0.1, which is different network, and we have seen that with the help of switch this type of thing is not possible. 10.0.0.2, right? This is a switch for 10.0.0.0 network. So here also on the other hand, since we are connecting more than 2 devices, I'm using switch on the other side also, so that we can connect more device also, right? And simply we can connect this switch, and hub and switch does not require any configuration. You have seen in all the practical, right? So now we are going to connect it like this way. Yes. So we have given IP address to both the network. Now we want to connect router. So for router we have a special configuration, please remember. And how we are doing that? We have to double click on the router, and then we go with the port through which we have connected. So click on this bubble, you will see which port it is. It's gigabit 0/0/1, right? So that is gigabit 0/0/1. So in that we have to give, or we have to switch on the port first of all, and then we have to give the IP address, right? That for this one, and you can see now half of the router is configured. So this network is configured on this side. Similarly, we will do for this router 1, and first of all we have to check the interface. So interface that we have is 0/0/1. So that we have 0/0/1, and here we have used the class C IP 192.168.1.3. I am taking it for this one, right? So we will check whether first of all this switch is working or not. You will find that it will successfully transmit and there is a successful transmission. Yes, between these two devices. So it means this network is working successfully. So if we work step by step, then there will be no error in communicate in this particular practical. Right? So you can see this PC, this network is also working because this is in same class. So this is working. Right? Now we have to see that whether we are able to send from PC here to PC this router. Yes. So this gateway is working and we can able to send our packet from this PC to router 1, right? But till now we have not configured the routers. So we are doing that part now. It is very simple. Please just be focused. So it is gigabit 0/0/0. So for that we have to give an IP address. So for this I am taking 13.0.0.1, and for this I am taking, depending upon the network that I have, so 13.0.0.1 I'm considering it. So you can see these routers, they are now active, and we will check partially that whether this is working. So we can see this from this PC to this PC we are able to communicate. From PC to router 0 we are able to communicate successfully. From this PC to this PC we are able to communicate successfully. From this IP to this we are able to communicate successfully. From router to router we can able to communicate successfully. Now how about from one network to different network, and you will see it will get failed. Yes class, can anyone tell me why this thing has happened? All devices who are immediately connected with each other, they are able to communicate, but when I am talking about end to end, then what I am getting fail message. Why it is there? Yes, anyone? Can anyone tell me why this thing is happening? Yes class, are you there? Yes. Who will say why this thing is happening? Please, no issue if you are wrong or whatever is coming in your mind, please tell why this thing is happening. End to end we are not able to transmit. Intermediate devices, they are able to communicate with each other, you can see successfully. From here to here, the router it is working. In between router and router it is working. From router to PC it is working. Then where is the problem? Yes? Anyone? Yes class? Why this thing has happened? Now this thing has happened because router is not maintaining IP table. We have not set routing protocol till now. That is what the role of routing protocol come in picture. Because we are dealing with a different network, and different network need routing table for packet transmission. Yes. So now I am going to set a routing table. So we have two configuration in it. First one is known as dynamic and second one is known as static. So today I'm talking about dynamic. So first of all we have to click on the router and we have to go for RIP, that is routing information protocol, and here we have to give the network address. So the network which we have used, please assure this thing that you don't need to apply here the IPs, you have to give the network only. So the network 10 is there, the network 13 that we have used, and the network 192.168.1.0 that we have used, right? One is there 13.0.0.0, That. So this router is configured. Similarly, the other router need to be configured. And on the other side, what we have 192.168.1.0, this network. Then we have 13.0.0.0, this network, and then we have one more, that is 10.0.0.0. So we have to apply these three networks. And now for first attempt, we will see that it is not able to deliver since the route is not found. So that's why the first attempt is always fail. And if you see that still it is failed. And the reason for that is that we have not set gateway. So that's why now the role of gateway come in picture. So for every node, we have to apply the gateway. So for this network 192.168, this is the gateway. That is 001. So for 001, we have set 192.168.1.3. So this gateway we have to set in our IP addressing scheme. So default gateway, that is 192.168.1.3, that we have to set. And for this also we have gateway, that is 10.0.0.3. As you can see over here, this is our gigabit 0/0/01. So gigabit 0/0/1, we have used 0.4, sorry. So we have to use 0.4 gateway, right? So please confirm before doing that. And now we will try to send our packet. So yes, there is some issue in between. There is a gateway 13.0/0. 1310 and 192. And similarly, we have 1310 and 192.168.1.0. Here we have set the gateway also 192.168.1.3, and just I am confirming the same gateway we have used or not. So for that we have to check for the interface. So this is the interface, and 192.168.1.3, this one is correct, and 192.168.1.3, this is also correct, right? Similarly, I am going to check on the other end also the gateway, that is first check the interface that I have. This is interface 0/1. So 0/1, 10.0.0.4, and this one is there. So going to check 10.0.0.4, and it is this one, right? Just going to check it first where the error is. This is successfully transmitted. This is also successfully transmitted. This is successful transmission. This is also successful transmission in between, right? Now check it for this one to this one. This is working. From this IP to this IP, we can able to communicate. From this IP to router number 0, we are able to communicate. You can see from different network, that is 192.168, we can able to communicate with